Now, you might be wondering, how is this enrichment? We've done this before, but it gets you into this lesson here on logarithms. So if you remember, we had a standard where a lot of you locked it. You have to simplify these expressions. So we're just going to make 3 lines instead of 3 boxes. So first, my bases are 4, and that's the only known numerical base, 4x and y. So the 4 is to the negative 2, but when it's in parentheses, I got this outside 2, so I need to take negative 2 times 2, and that's negative 4. And the x, negative 2 times 2, negative 4, and then there's another x, okay? Now they're both on top of the line, so we need to add those, and we're just going to add 3. Okay, negative 4 plus 3 would be negative 1, and then the y, 3 times 2 would be 6, and that's the only y. Now, if it had a negative power, it needs to go into the other side of the line. So the 4 goes to the bottom, and then that becomes positive 4. Likewise with the x, and y to the 6th. Now, we need to simplify the 4 to the 4th power. Okay, that means 4 times 4 times 4 times 4. That is 256 times x to the 1, and that's the answer. Okay, now this one here, my bases are 3 and x. And 3 is to the 1 power, but it's in parentheses with an outside of negative 4. It means that belongs to everything in there. So 1 times negative 4 is negative 4. Then the x is to the 1, and that'd be negative 4. Now we need to move those both to the other side so their exponents turn into positives. And I need to cover the numerator with a 1 then. Okay, so it's 1, 3 to the 4th is 81 times x to the 4th. Okay, now you're going to learn a little something new. It's logarithms, okay? And don't take the notes down. It's just enrichment. So, and we're going to solve these equations where you see a logarithm, okay? And it says log base 8 of 64 equals x, okay? Now, first off, here's what a logarithm really means. It means you're going to write an equation with an exponent. So 8's going to be your base. That little number right there is your base. And then what's on the other side of the equation is actually the exponent. So it's 8 to the x power, and then it's equal to 64. Okay, just like that. Now what you want to try first is you want to find out how many 8s it takes to multiply and get a you don't divide both sides by 8, okay? Because 8 to the 8th, because 64 divided by 8 is 8. Well, 8 to the 8th power is not 64. It's way higher than 64. So what I do is I write 8s out until I can multiply to 64. So there's 8. That's not equal to 64. But if I put a second 8 down, that's exactly equal to 64. So how many 8s is that? It's 2. So x equals 2. 8 to the second power equals 64. Makes sense? Okay, now I'm going to get my calculator here. Okay, now we have a base of 3. So this right here, you're going to write a big 3, and then that's going to be to the x power. It's going to equal 81. So it means how many 3's does it take to multiply to 81? So there's 1 3. That's not 81. Well, that's 9. We're not at 81 times 3. Now it's 27. We're still not equal to 81 times 3. I don't know. You know, you might lose track. That's why you have a calculator. I know that's 27. That's 81, okay? So how many 3's did that take? 1, 2, 3, 4. So x is equal to 4. Okay, next one. We have a 4 to the x power equals 1024. Let's try to figure out how many 4's it takes to multiply to 1024. So there's 1. That's 16. Again, if you lose track, you have a calculator. So that's 3. Nope, not there yet. 256. I have not gone over 1,024 yet, so I keep. Now, sometimes you end up going over the number. Well, then you have to do something different, but there we go, okay? So that equals 1,024. So how many 4s did that take? 1, 2, 3, 4, 5. So x is equal to 5. 4 to the 5th power equals 1,024. Okay, now I'm actually going to come back to this one. So the logarithm's base is 1/4. So that means 1/4 to the x power. You want to parenthesize a fraction equals 16. Now forget about the fact that it's 1/4 and just ask yourself how many 4s does it take to multiply to 16? If it was just a 4, not a 1/4. So 1, 2, and that equals 16, okay? So it takes 2, but since it's been reciprocated, and instead of 4, it's 1/4, then the power is going to be negative, okay? So x is equal to -2. Because they'd switch places, you know what I'm saying? They'd both have a negative exponent, and they'd just move top and then bottom, okay? Okay, the next one, the base is 5. So 5 to the x power equals 1 over 25, 1 over 125, okay? Once again, forget the fact that it's 1 over 125 and just figure out how many 5s it takes to multiply to 125. There's 1, there's 2, and I don't know, does it? So 5 times 5 times 5. There we go. Equals 125. Okay, so that took 3 5s, but it's been reciprocated, okay? Instead of 125, it's 1 over 125, so I just make my exponent negative, and that does the job for me. Now, I'm going to come back and do this problem. You want to pause the video probably, and you want to do 1 through 4, okay? And after 1 through 4 is done, you're going to unpause it and then come back. Okay, log base 7 of 20 equals x. So 7 is the base, and it's to the x power equals 20. Now you run into a little problem here. That's already at 49. So basically, there's not a clear-cut number of 7s that can multiply to 49, okay? And you're like, well, it's somewhere between 1 and 2 because 7's not too small. 1 7's too small, but 2 7's is too high. Well, here's how you figure out your exact answer when you can't multiply the factors to reach the product. You're going to circle the power and then split the base and the exponent. And what you're going to use is a formula. You take whatever's the exponent, which in this case is just x, and you write equals, and this is going to look funny, log over log. And you need to put this 7 on the bottom, whatever the base is, whatever's here with the exponent goes on bottom, and then what it's equal to goes on top. And then you're like, well, how do you figure that out? Well, you do it on the calculator. So you have this log button right here below the second one. So log, and I have a 20 in the numerator. I need to close the parentheses, and then I divide by log 7. Close the parentheses. Okay, 1.54. Okay, round to the nearest hundredth, there was a 9 there. Okay, and that's how you handle it when you can't get it to multiply out. Okay, so the next page, so I've got 2 to the x power equals 8. Okay, so let's figure out how many 2's it would take to multiply to 8, if that's possible. So 1, that's 4, and I believe that equals 8. So how many 2's did it take? It took 3. Okay, my next problem, 4 is your base to the x power equals 1 over 64. Now, again, forget the fact that it's a fraction. Just pretend it's 64, okay? So 4 times 4 is 16 times 4. Let's see what that is. Okay, 64, all right. So how many 4s did that take to make a product? It took 3. But since it was 1 over 64, we just make our exponent negative. Okay, so 4 to the negative third power equals 1 over 64. Okay, my next problem. I have a base of 5 to the x power equals 30. I've got a bad feeling about this, so there's 1. That's not enough to make 30. Now I'm at 25, and I don't know what that, it's 125. That's well over 30, so that did not work. Okay, that failed. So when it fails, you want to circle the power and then split the base from its exponent, and you use a formula. Your exponent, which is x, equals log over log. Log divided by log. You put 5 in the denominator and 30 in the numerator. Because you know this has to be between 2 and 3. Because 2 is at 25, not enough to make 30, and that's too much to make 30. So I take log 30, close it, divided by log 5, close that. Remember to close your parentheses. They'll open up automatically. You just got to close them. So 2.11. Okay, next problem. This one's slightly different. So you got 8. And the power's not going to be x. The power's going to be 4x, because on these all you have is x. So it's 8 to the 4 times x power equals 59. Okay, well, let's figure out how many 8s it takes to multiply. Well, anytime I have something other than just x, you know, when there's like something with it in the power, you want to not do the list of factors. You want to do circle it and split it. So your exponent this time is not just x, it's 4 times x equals log over log. So 8's in the denominator. That is always the case. You always put whatever's there in the denominator, and then 59's in the numerator. So we got to figure out what that divides to. So log 59, close it, divided by log 8. That's 1.96. But it's 4 times x equals 1.96, so I need to undo the multiplication by dividing. Okay, so I divide 1.96 by 4, and I get an answer of 0.49. Okay, next page. The base is 7. And the power is going to be, yes, that whole thing is going to be our power. 2x plus 1 equals 65. So I don't want to try to list out 7s to multiply to 65. So I'm going to circle and split. And the power, which is more than just x, it's 2 times x plus 1, is equal to the log divided by log. And 7's in the denominator, and 65's in the numerator. So I need to divide that on the calculator. That tells you how many 7s it takes to multiply to 65. Whoops, sorry. You got to hit log twice. So 2.14 rounds up to 1.5, but it's 2 times x plus 1 equals 2.15. Okay, and then I need to solve for the x, I need to subtract 1. So it's going to be 1.15, and then I divide by 2. Okay, 0.58. Okay, my next problem. The base is 4. The power is going to be negative 5 times x equals 86. Okay, so again, I'm not with this 5 here with the x. I would not want to worry about trying to multiply 4's out to 86. I would want to know that your power, your exponent, negative 5x, is equal to log over log. And whatever's the base goes on bottom. A lot of people think, oh, smaller always goes on the bottom. No, it's whatever's here. And then 86. Okay, so I divide log 86, close it, divided by log 4, close that. I got 3.21. So negative 5 times x equals 4.21, and then I need to divide by negative 5. Negative 0.84. Okay, next up, the base here, 1.005. And the power is going to be 4x equals 2.105. You can do decimals. Okay, why can't you? So again, I have no idea how many of these it takes to multiply to this. So I split it, and 4 times x equals log over log. So that base goes on bottom, and this goes on top. Okay, so 4 times x is going to equal whatever this divides to. I mean, who knows? Log 2.105, close it, divided by log 1.005, close the parentheses, and it's 149.23. Just go 149. I'm not real picky about rounding. So I need to divide 149 by 4, and that's 37.25. Okay, in this one I have a base of 8 to the x power equals 73. So it's just an x power, so who knows, maybe I can get the 8s to multiply to 73. That's 64, and that's way over 73. So nope, that failed. So x equals log, and I put 8 on the denominator, 73 in the numerator. That's what a log does. It's used to figure out what exact power it's to. Whoops, sorry. Okay, 2.06, and I have just the x by itself, so I don't need to add or subtract or divide, and it's 2.06. Okay, now you can probably know enough that you can do the rest, 4 problems on the back. Remember, this one here, these are more than just, it's 3 to the 5x power equals 55, 2 to the 9x plus 1 power equals 14.